welcome. Today we will be going over study problem 5-6 from our textbook again. We have an investor. She would like to make a single investment, single payment today, so that she can accumulate $2 million in 35 years during the time of her early retirement. She knows that she can earn 4% each year through that investment, through that mutual fund investment, and the question is, how much does she need to invest today? And then the question also asks how much she could have earned if knowing that she can make 14% annually. Alright, so given this information, it is quite natural that we have you may consider two different approaches to solving this problem. So one way would be to use basically a formula, a present value formula basically, and so that's the first method. A second method would be simply to use the financial calculator. So both methods should provide the same answer reasonably. So using the formula, we already have a formula for the present value for a single payment though, so it's future value divided by 1 plus the interest rate raised to number of accumulating years. In our case, the future value we would like to accumulate is $2 million, dividing it by 1 plus 0.04% each year we can earn for 35 consecutive years, and you do the math, $506,831, and that would pretty much give you the answer. Using a financial calculator, life will be similar. So we will have N over Y, PV, payment, FV. This is basically the gray row on your TIBA2 plus financial calculator. That would be the second row from the top. So N stands for number of years. We are investing for 35 years. I over Y stands for the interest rate that can be earned. In our case, it would be 4%. The present value is pretty much the question mark that we are seeking. The payments are basically zero. This is not a stream of payment problem. It is one-time single payment, how much we can accumulate down the road. And the future value is $2 million. And that's pretty much it. So you would just compute PV, and lo and behold, you get pretty much the same answer. So it is almost straightforward. Alternatively, one would wonder for the second part of the question, let me just try to do it right underneath, how much would we have to invest if we could have earned 14% instead of 4%? That part is no different. So N I over Y, PV, payment, FV, again, so we have 35 years, but this time instead of earning 4%, we can earn 14%. Again, the question mark is the present value. There is no single payment, and future value is to be $2 million. You compute the present value in this occasion. It's quite shocking that just a single investment of $20,000, slightly more than $20,000, would be sufficient in that occasion if you can guarantee a 14% return annually, year after year, for 35 years. That would grow into basically $2 million. Just for the record, I want to make a quick calculation just to make sure that our answer is reasonable. So I'm just drawing this box here, in this imaginary box. Focus on the first part of the problem where we are earning basically 4%. So we said that roughly a $500,000 investment should suffice for our money to grow into $2 million, basically to quadruple in 35 years. Is it meaningful? Well, we can consider the rule of 72. According to this rule, it would take 72 over 4%. This is how much we can earn annually. Roughly 18 years for our initial investment to double. Because our initial investment was $500,000, it will take 18 years for that amount to grow into $1 million. and further another 18 years to double again from $1 million to $2 million. So 18 years during the first phase, 18 years during the second phase, and sure enough, our answer is quite reasonable, right? So it would roughly take 35, 36 years for our money to quadruple, and pretty much that's roughly what we got as well. So it kind of shows that our calculations make sense. In a similar way, you can consider for yourself what would happen if you apply the rule of 72 in the case where 14% is the interest rate. But that pretty much completes our solution.